All right, everybody, we are back at it. Today we're going to take a look at what is known as point-slope form, and this is Chapter 3, Section 9. So we've covered slope-intercept, standard, and point-slope, and there are a lot of similarities between all three, but I want to compare point-slope and slope-intercept form. In slope-intercept form, we knew we had a starting place for the graph. It was where the y-intercept was. In point slope form, we're also going to have a starting point, and it's going to be what we call a known point. So just keep that in mind as we go through and look for the similarities between point slope and slope intercept. So let's get to the definition part first, okay? All right, so in its general form, point slope form is y minus y sub 1 equals m times x minus x sub 1, but we better define what some of those variables are, because we don't want to just go charging off and not have any idea what the letters all stand for. Well, m is pretty obvious at this point. We've been universally using m as the slope. Now, we have a couple x's, we have a couple y's. You'll notice that one of the x's is labeled x sub 1, that's x, and then the word sub sub 1, and y sub 1. Keep in mind the ones don't have any mathematical meaning. They're just there to differentiate between the two different x's and the two different y's. We say that x sub 1, y sub 1 is a known point. So that's going to be our starting point. We know the location of that point on a graph. X and y, so just plain x and just plain y, are what we call open variables. That is, x is going to represent the input and y is going to represent the output we get. Well, I think the easiest way to do this is if we start by looking at graphing. So we're going to look at an example of using point slope form for graphing. So I've got this. Given the graph, write an equation in point slope form. So what I've got here is I've drawn a line across mostly just quadrant 1. You can see it, it's going right up here, and I know it goes through the point 3, 4. So what I want to do is I want to write an equation for this line in the point slope form. So first thing I want to do, and I recommend this all the time, is write the equation in its generalist form. So y minus y sub 1 equals m times x minus x sub 1. And then go figure out the pieces that you know. From the graph, I know this point, 3, 4. So I'm going to label that x1, y1. x1 is 3, y1 is 4. And also from the graph, I can determine what the slope is. I noticed that to go from point to point, it has a rise of 2 and a run of 1. So m or slope equals 2 over 1. We could just say that's 2. So I have the slope, I have the x1, y1, I can plug that information in here. And I get y minus y1 is 4 equals the slope. Why did I write, no. Yes, that's correct, 2 times x minus, and x sub 1 is 3. Well, that's it. This is the equation in point slope form. We don't want to do anything else. We don't want to distribute the 4. We just leave it in this format right here. So this is in point slope form, just like that. From point slope form, you can see you could pull out the known point as 3, 4 because you can see those numbers, and you can pull off the slope because you can see that number. Well, let's look at a different variation here. So now, if I gave you the slope and a point, the question becomes now, write an equation in point slope form. Really, we have the same information that we had up in this previous problem, except now instead of you having to get it from the graph, it's given in the problem. Slope is slope, and 2 is your x1 value, and 5 is your y1 value because it's the known point. Again, start with y minus y1 equals m times x minus x1. And just plug in the information. Y minus y sub 1 is 5 equals the slope, which is 3, times x minus x1, which is 2, and then stop. Don't feel like you have to simplify it. Don't feel like you have to distribute the 3 at all, okay? Let's try another one. Write the point-slope equation of a line that goes through the given point with the given slope. Now, these two questions are asking the same thing. The reason I did it two different ways is the wording's very different, and I don't want you to get confused because, you know, I don't want to show you this way and have this show up on a placement test, or other way around. I show you this way and this shows up on a placement test and you get confused. It's asking the same thing. I lost my green pen. There it is. So we have the x1, we have the y1, and we have the slope. Y minus y sub 1 equals m times x minus x sub 1. And we simply plug that information in. This becomes y minus 7, because that's y1, equals m, which is 3 over 4, times x minus, but here's a catch. I am subtracting a negative 3. So there's the operation, and there's the qualifier. So this is minus a minus, which makes this plus 3. Okay? So same question, just different formats. The other thing to pick up is when you're subtracting a negative, remember to make that a plus. So a few things were being taught to you there. All right, let's pull up the second page of the notes. Remember, if I'm going too fast, pause, rewind, whatever it takes for you to follow along. Okay, given, now I'm going to give you the equation, y minus 2 equals negative 3 over 2 times x minus 3. This is find the slope and a point on the line. So now we're going the other direction. Instead of me giving you the point and the slope, you write the equation. I'm giving you the equation, and you have to tell me the other information. So I'm going to start with y minus 2 equals negative 3 over 2 times x minus 3. Okay, below it, write the general form. Y minus y sub 1 equals m times x minus x sub 1. Notice how everything's lining up? So I can write, hey, look, y sub 1 is 2. The slope is negative 3 over 2. X sub 1 is 3. So it's very simple to go, okay, x1, y1 is 3, 2, and the slope is negative 3 over 2. Okay? Very simple. Just pull that information right out of the equation. But I'm going to show you the next example because I want to caution you a little bit. It's the same setup. You're given the equation and you have to find a slope and a point. So I've got y plus 5 equals 1/2 times x plus 3. Below it, y minus y1 equals m times x minus x1. Well, let's get the easy one out of the way. The slope is 1/2. I don't have to do a lot of thinking there. But now we got to be careful. If subtracting y1 is plus 5, then y1 has to be negative. Okay? If it's subtracting y sub 1, but it ends up being plus, that tells you that the y sub 1 value is going to be negative. And by the same logic, the x sub 1 value is going to be a negative as well. So x1, y1 is, we'll look at it this way. If negative x is positive 3, then positive x is negative 3. If negative y is positive 5, then positive y is negative 5. And the slope equals 1/2. Okay, so that one's there just to caution you about keeping track of the negatives. That's a tricky part. Like, people miss that all the time on test questions. Slow down, just be very conscious of what the negatives are showing you, okay? Given 2, 5, and the slope is 1/2, write equations in point slope, slope intercept, and standard form. So now we're going to start bringing all three forms together. We're going to weave them together. I think the easiest place to start is, since we are given a point and a slope, let's start with point slope form. 2 is my x1, or 5 is my y1. So y minus y sub 1 equals m times x minus x sub 1. And I can plug in the information. There's the slope, there's the x, there's the y. So y minus 5 equals 1/2 times x minus 2. Done. That is point slope form. Okay, so we've got the first one. Now it says go into slope intercept form, so we can do that. So I'm going to just rewrite the equation. I'm just going to drop it down, rewrite it. I've got y minus 5 equals 1/2 times x minus 2. All right? What I'm going to do now is distribute the 1/2 into the x and the 2. So I've got y minus 5 equals 1/2 x minus 1. 1/2 times negative 2 is minus 1. I just need to get the y by itself, so I'll add 5 to both sides. 5's cancel, and y equals 1/2 x plus 4. And boom, there you go. That is slope-intercept form. Okay? Now I'm going to grab that, come up over here maybe, and rewrite it. Y equals 1/2 x plus 4. Now I've got to move the x term over in front of the y term because we're going for standard now. So I'll subtract 1/2 x from both sides. These cancel, and I get negative 1/2 x plus y equals 4. But I can't leave it like that because I have a fraction and the a term is negative. So to take care of this, I'm going to multiply the entire equation by negative 2. The negative here will cancel the negative there. That'll make the a term positive. And 2 times 1/2 will turn that into a 1. That'll be an integer value. So we distribute this across. And negative 2 times negative 1/2 is 1x. I'm just going to put x plus negative 2 times negative y. Okay, so that's not plus. That's minus 2y equals, and negative 2 times 4 is negative 8. I'm going to rewrite it because that looks a little clumsy. X minus 2y equals negative 8. So there you go. That's standard form. Okay? So we started with point slope because we were given a point and a slope. Very easy to convert that to slope intercept form. And then I just went through whatever steps I had to get to standard form. Now, you may find that the steps aren't exactly the same in some of the ones you get to do, but you get the general idea. Okay? Next page. All right. Given the point 1, 4 and the point negative 1, 1, write equations of the line in point slope and standard forms. Okay, now this time you're not given the slope. But if you have 2 points, you can calculate the slope. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, we get that. Label your points x1, y1, x2, y2, and plug this information in and you'll have the slope. So this becomes 1 minus 4 over negative 1 minus 1, which is negative 3 over negative 2, which we can rewrite as a positive 3 over 2. 3 over 2. So there you go, we've got the slope. It was really all we could do given 2 points. Now that I have the slope, I can go to point slope form. It's a logical place to start because I have a couple points and I have a slope. It doesn't matter which of these 2 points you choose. So choose the one that makes the arithmetic the easiest. I suspect Most of you are going to grab the first one just because. So I'll start with that one, but I want you to know ahead of time that you could have picked either point. And you should have picked that up from one of the last lessons. All right. So start with point slope form. Y minus y sub 1 equals m times x minus x sub 1. So I'm going to use that x1, that y1, plug them in with the slope. So y minus 4 equals 3 halves times x minus 1. Again, I pulled those numbers for x and y, x1, y1, from right there. Now, boom, you're done. You got it. And just in case you did do this one, let's write that down as well. We could have written y minus 1 equals 3 halves times x plus 1. That's if I had used that point. Now we want to put this into standard form. So let's go standard form and see what we do now. I'm going to bring this down. It doesn't matter which one you bring down, both the same. I'm going to bring down y minus 4 equals 3 halves times x minus 1. And we're going to put that in standard form. First thing I think I want to do is multiply both sides of the equation by 2, or multiply the entire equation by 2, because that'll get rid of the denominator. Trust me, you could have started by distributing the 3 halves. That would have been fine. Just this problem, I think I want to get rid of the denominator first, but you could have distributed the 3 halves. So like I've always said, there are lots of ways to do these problems. So 2 times y minus 4 and 2 times 3 halves. So we get 2y minus 8 equals 3 times x minus 1. Now, a lot of people are probably wondering, well, how come you didn't multiply the 2 times the x minus 1? Well, here's the difference. Y minus 4, those two things are separated by addition or subtraction. So I have to do it to both. But over here, this is separated by a multiplication. See, the x plus 1 is being, x minus 1 is being multiplied by 3 over 2. So I only have to do it once. Okay? And I get 2y minus 8 equals 3x minus 1. Now you can distribute 2y minus 8 equals 3x minus 3. Now to get it in standard form, the 3x has to go in front and the 8 has to move over. Maybe I add the 8 first. Doesn't really matter. So that's 2y equals 3x plus 5. And I'll subtract 3x from both sides. And I get negative 3x plus 2y equals 5. And to get rid of that negative, multiply the entire thing by negative 1, and you get 3x minus 2y equals negative 5. So a lot of steps there, but nothing that you can't handle. I think you guys have got that no problem, okay? Okay, last page. And this is going to be showing you how to graph from point-slope form. So we have the equation y minus 2 equals negative 3 halves times x minus 3. So y minus 2 equals negative 3 halves times x minus 3. Below it, y minus y sub 1 equals m times x minus x sub 1. Okay, x1 is 3, y1 is 2, and the slope is negative 3 over 2. So my known point, x1, y1, is 3, 2, and my slope is negative 3 over 2. Well, I'm going to start with my known point. Over 3 up 2, so there's the known point, 3, 2, and that's my starting point. So from there, I'm going to run out down 3 over 2, or I can go up 3 and left 2, up 3 and left 2. And if I can find my straight edge, I can graph that line. So that's how you take an